class to another video. What we're going to cover today is learning how to compare key features of different functions and where they're each represented in multiple ways. So we have an opening problem here. So it says the function d of t represents Gulliver's distance d from home after t hours. Use the graph to answer the following questions. So I'd like you to pause the video, maybe try this on your own. So I hope you gave this a shot. So again, when we want to start identifying the independent variable x and the dependent variable y, we should look at the labels of the x and y axis. In this case, the variables are sort of changed because t is representing x and d is sort of my output variable here. So I look at my label, my horizontal axis, so it is time, the input in hours, and the output, or the d variable in this case, or y, is the distance from home in miles. And it can be nice to put the units here. So then the next question is having me evaluate this function using function notation. So let's recall that when we see function notation, f of x is equal to y. So remember, whatever is inside of the parentheses is the input, and when you evaluate it at that input, it will be equal to the output. So d of 2 here is asking me when the time is, when 2 hours have passed, what is the output? So you need to look on the x-axis at 2, you find it, and then you have to go either up or down, up in this case, to find the y value when the time is 2, and it looks like after 2 hours, Gulliver is 4 miles from home. So you're going to do this for sort of all of these. So I encourage you to try these on your own before I get them done. But d of 7, so I'm going to look at 7, my input, and I need to go either up or down, and it's again up in this case, to find the y value when the x value is 7. So I look, and it looks like after 7 hours, Gulliver is 10 miles from home. All right. Last one, d of 10. So same thing, I look on the x-axis, 10, what is the y value here? Well, it's actually at 0. So it looks like Gulliver is back home after 10 hours. The output is 0. All right. And in 4 and 5, we're being asked something different, right? It's now asking us to find the x value when the y value, or when d of t is equal to 4. So now I'm going to just get rid of my highlighting and use the same kind of method. So I look on the y-axis, it's 4. I want to know at what time is, and for this there can be multiple ones, right? So I look here, and when is the, at what time is his distance from home 4 miles? Well, it's when t is between 2 and 3, and when t is equal to, and we'll have to kind of estimate here, so maybe I'll say roughly, make an equal sign that looks a little wavy. That means approximately. So I would say that that's about, I don't know, 8.75. You can do the same thing, but now we're concerned when d of t equals 5. So again, I do the same thing. I look, where is my graph have a height of 5? So I see that it has the height of 5 here at x equals, or sorry, t equals 4, and as well right here, which looks like right in between 8 and 9. So, and t equals 8.5. Right. So when we're given a graph and we're asked questions like this with function notation, we just need to remember, if we have to first look for the input, in which case we should look on the x-axis, find in question 1 it was 2, and then follow that up to find the y value. Or in numbers 4 and 5, we're given a y value and we need to determine at what t value is the graph equal to 4. And there can be more than one answer, right? All right, good. And then lastly, it says describe the graph from 7 to 10. So I want to describe the graph from 7 to 10. So what would I say? Would I say that the graph is increasing, decreasing, or constant? Well, it's going down from left to right. So graph is decreasing, right? And you could say that Gulliver, is that how you spell his name? Yeah. Gulliver is going home because his distance from home is decreasing. So he's going towards home. And then finally, what is the furthest Gulliver traveled? So what is the maximum distance that he got from home? So you look, what's the highest point of the graph? It is right here. So the maximum distance from home was 11 miles. All right, so this opener, you know, it's a little bit of review of how to sort of read a graph, how to get information from a graph. All right. So pause the video, make sure you have this written down. All right, let's continue. So example 1 says a portion of a quadratic function f of x is shown in the coordinate plane. Selected values of a linear function g of x are shown in a table. So we'll study exactly what a quadratic function is, but it's just telling me that this is f of x. Okay, it's given to me as a graph. And the second function, g of x, is given to me as a table. So what we want to be able to do here is we want to be able to go from a table, or I'm sorry, a graph to a table and a table to a graph. So how would we do that? Well, you're going to be given the inputs, and it's going to be all points that are already on the graph when I give you these. So when you look at -5, okay, so -5 shows up right here. What is the x value? It's -5. So I need to write down what the y value is. So I need to write the y coordinate of that point. So in this case, it's just 0. And it's kind of just like I'm reading the graph again, right? So I see the x value is -5. What's the y value? 0. X value is -3. Okay, what's the y value? Again, remember, ordered pairs are x comma y. So, and remember f of x is the same as y, or the output. So when I look at negative 3, I want to look at the y value of that point, and then I'm going to just write it down in my table. So in this case, it would be negative 4. So now I can look at negative 1, y value is 0, 0, the y value is 5. So it's kind of like you're copying the right information from the graph into the table. Okay, hopefully that is fairly easy for you guys. So then we can do the other way around, where we're given a table and we need to plot those points. Okay, and again, we're given points x comma y. So I need to plot the point negative 5, negative 10. So, if you want to look on the graph, so you'll go to the left 5 and then down 10. So that would be a point. All right, then. So I'm done with this one. So now I'm going to move on. Negative 3, negative 4. Okay, so negative 3 would be to the left 3. Negative 4 would be down 4. So that would be this point right here. All right, negative 1. So again, x to the left. And now y value is 2. So you go up 2. That one's done. And then lastly, 0. So the x value kind of just stay in the middle. And then up 5. And because it told me that this is, a linear function, it does sort of make sense that this would be a line, straight line when I graph it. And we will, study linear functions more in depth in the next coming units. Good. But really for today, we're focusing on going from a graph to a table, table to a graph. All right, good. So now what we can do is compare sort of the key features in these two functions. So if I want to think, what is f of negative 5? Well, I can look at my table. The input, negative 5, output was 0. I can look at g of x. Input, negative 5, output was negative 10. And then I can compare those. Which was larger? F of x or g of x? Well, 0 is greater than negative 10, so that is greater, right? F of negative 1, so again, look at that table. F of negative 1, find the input of negative 1. What is the output? 0. Same thing for g. Find the input. Let's scroll up a little bit here. G of negative 1, so find the input, negative 1. What is the output? 2. And then we can compare these again. So g of x is actually larger at that value. 2 is larger than 0. All right, then we can think of what is the minimum. What is the minimum value of f of x? So again, this was, you should make sure that these have arrows to signify that they keep going. So this function f of x, because these keep going in the up direction, this is not going to have a maximum, but I do have a minimum because this graph sort of looks like this valley. So my minimum will be this point right here, negative 3, negative 4. So the minimum value, the minimum y value of this function is negative 4. Whereas if I look at g of x, this graph goes it keeps going in the positive up direction and it keeps going in the negative down direction. So the minimum value of g of x, if it keeps going down forever, would actually be negative infinity. So if the y value is negative infinity, or the minimum is negative infinity, well, which one has a greater minimum? Well, negative 4 is larger than negative infinity. All right. Then we can compare, the key features that we talked about the other day. So x-intercepts, y-intercepts. So let's look at what is the y-intercept of f of x. So this is f of x. Where does it cross the y-axis? Well, it crosses the y-axis right here at this point, 0, 5. What is the y-intercept of g of x? So again, same thing, right? Where does the graph cross the y-axis? Crosses again at same place, actually, 0, 5. So let's write that as an ordered pair. Good. So both of these functions actually have the same y-intercept. Then we can describe the functions. So how would we be able to describe f of x from negative 3 to 0? So from negative 3 to 0, well, would we say that this is increasing, decreasing, or constant? So I would say that the function is increasing. Describe the function g of x from negative 3 to 0. So again, same thing, from negative 3 to 0. Oh, well, this one is also increasing. So this function g of x is also increasing from negative 3 to 0. All right, and we will stop the video there. If you guys would like to try example 2 on your own, um, that would be great. You can pause the video, try that, and we will go over the solutions